Diffusion over a Membrane by Jed Lin and Andrew Sharp.
I was learning how to make coffee, as I had never had it before. Unfortunately, I assumed that it made no difference how many filters I used since they were so thin. So therefore, I placed multiple filters. To no one else's surprise, the coffee was bland. Why is that? Now we heard of diffusion. It is a transfer phenomenon that does not require bulk motion. After research, we found that diffusion is caused by Brownian motion. Brownian motion is named after Robert Brown, who first discovered pollen grains seemingly moving in water at random. Several decades later, Albert Einstein published a paper explaining that Brownian motion is simply the movement of atoms and molecules due to collision with other atoms and molecules. Seen here by Fick's equation, movement of liquid across the membrane is controlled by the change in concentration over the change in distance and the diffusion constant. In the coffee mishap, the distance x was controlled by the number of filters or membranes that the coffee had to diffuse through. Since the coffee grounds were placed behind multiple filters, it took much longer to fully diffuse evenly.
We hypothesized that more filters would yield a lower diffusion rate, as stated in Fick's equation. We set up a container with a coffee filter placed right in the middle and observed the time spent for it to completely diffuse over. This is the result of one filter. This was the result of the 3-filter experiment. This was the result of the 5-filter experiment. The results of our experiment backed up our original hypothesis that increasing the number of filters would linearly increase the time it takes to diffuse across the membrane. This was a good demonstration of diffusion in Fick's first law. Thanks for watching.